This is how to wire a voltage regulator, and the diagram is on screen right now. A battery, an alternator, the warning lamp, a chassis ground, and the little regulator that holds the whole system at about 14 volts. Drawn clean in a free browser tab. By the end of this video, you will trace the field wire and the sense wire and read every terminal. You will also know why a bad regulator either flattens your battery or boils it. So let us take this charging diagram apart, piece by piece. So what does a voltage regulator actually do? Your alternator can make far more voltage than the battery ever wants. Left alone, it would cook everything electrical in the car. The regulator is the referee. It senses the system voltage, and it controls one thing only: the field current feeding the alternator's rotor. More field current, more output. Less field, less output. The regulator trims that field thousands of times a second to hold the system between about 13.8 and 14.4 volts. Think of it as a loop. Read the voltage. Compare it to the target. Nudge the field up or down. Read again. That loop is the entire job. Hold 14 volts, no matter the engine speed or the load. Quick note before the wires. This exact charging diagram is free to open in your browser at circuitdiagrammaker.app. No install and no sign up. Full disclosure, the editor is ours. Open the first link in the description and follow along. Right, the terminals. A voltage regulator really comes down to 4 connections. Get these straight and the rest is easy. 1. Battery or sense. This is the wire that reads system voltage, usually straight off the battery or the main output stud. It is how the regulator knows what is actually going on. 2. Field, sometimes called excite. This runs to the alternator's rotor field, and it is the wire the regulator switches to control output. 3. Ignition, a switch 12 volts that wakes the regulator up when you turn the key, so it is not draining the battery while parked. 4. Ground. Every regulator needs a solid ground reference, or its voltage readings drift and it charges wrong. Battery and sense in. Field out. Ignition to switch it on. Ground to steady it. Let us wire the simplest version live in the editor. One quick safety note first. On a real car, disconnect the battery before you touch any charging wire. Here is only a diagram, so it is perfectly safe to draw. I will drop in a source, a switch for the ignition feed, a load, standing in for the field, and a ground. Then I connect them into one loop. Watch the wires. Every connection routes itself, pin to pin. Move apart, and the wires follow it, so the drawing stays readable while you think. That is the skeleton of every charging circuit. Power in, a switch to turn it on, the regulated load, and a return path to ground. Now, the part that confuses everyone. The little battery light on your dash. That warning lamp is not just a warning. On most cars, it actually helps start the alternator charging. Turn the key, and current flows through the lamp to the field. That small feed excites the rotor just enough for the alternator to begin making its own power. Once it is spinning and charging, both sides of the lamp sit at the same voltage. No difference, no current, so the lamp goes dark. That is why the light glows at key on and vanishes when the engine catches. If it stays on while driving, the charging system is not keeping up. One big question: is your regulator inside the alternator or outside it? Most modern alternators are internally regulated. The regulator is a small module built right into the back of the unit, so you see fewer wires. Older cars, tractors, and a lot of marine setups use an external regulator, a separate box you can test and replace on its own. And on motorcycles and quads, you will meet a regulator-rectifier or rec-reg. It does 2 jobs at once. It converts the alternator's raw AC into DC, and then regulates that voltage for the battery. Here is the part paper can never do. Prove it. This editor has a real simulation engine built in. Load the charging diagram, run an operating point, and live voltages appear right on the drawing. There is the battery feeding the system, a clean 0 at the chassis ground. Numbers computed from your actual wiring, not guessed. Ground the regulator to the wrong point or feed the field from the wrong side, and the values tell you now. On screen, in seconds, not later, stranded with a dead battery. Before you touch anything, learn the 2 failure modes. Overcharging is a regulator stuck high. The lights burn bright, the battery runs hot and gases, and you may read over 15 volts. That cooks batteries and kills electronics. Undercharging is the opposite, a regulator giving too little. The battery slowly goes flat, the lights dim at idle, the warning lamp glows, and you read under 13 volts running. So measure at the battery with the engine on. Around 14 is healthy. Way over or way under, and the regulator is your first suspect. So that is how to wire a voltage regulator, the honest way. Battery and sense in. Field out to the rotor. Ignition to switch it on, and a solid ground. Hold 14 volts, and the charging system just works. The editor is free at circuitdiagrammaker.app. No install, no sign up. The link and a gallery of real diagrams to copy are in the description. Want the full car build next? There's a car wiring walkthrough and a relay tutorial waiting on the channel. Subscribe, and I will see you there. Thanks for watching.